Morning students. The previous class we have learned about the proper and improper fractions, and we have learned some methods to resolve into the partial fractions, and type 1 type 2 deals about the denominator contains non-repeated linear factor type 1 and repeated linear factor type 2. So these are what we have discussed. So today irreducible and reducible polynomials. Reducible polynomial. If a polynomial f of x can be expressed as the product of two factors. If a polynomial can be splitted or decomposed or factorized into two or more factors, then that kind of a polynomial is said to be reducible polynomial. So here the degree of b less than that of a degree of f of x. So a polynomial f of x is said to be a reducible polynomial if it can be expressed as the product of two factors or two polynomials g of x and r of x, where degree of each g of x and r of x is less than the degree of f of x. So then that kind of a polynomial is to be a reducible polynomial. If you take an example, x square minus 1 is x square minus 1. So this can be expressed as a product of two polynomials. So this is x minus 1 into this is x plus 1. So this is a polynomial and these two are also polynomial. Let us suppose that this polynomial is f of x. So this f of x can be written as x minus 1 and x plus 1. Individually they are all the polynomials only, and here the degree of f of x is 2. Here degree of g of x and r of x are having 1 each, and this 1 is less than the degree of f of x. And if you take x square minus 3x plus 2, this is also x minus 1 into x minus 2. This is also a reducible polynomial. And even x square if you take, this is x into x. And if you take x cube minus 6x square plus 11x minus 6, so this can be written as x minus 1 into x minus 2 into x minus 3. So these are all the reducible polynomial. And irreducible polynomial, a polynomial f of x is said to be an irreducible polynomial if it cannot be expressed as the product of two polynomials. So irreducible polynomial. A polynomial f of x is said to be irreducible. So if it cannot be expressed as the product of two polynomials g of x and r of x. So x minus 1. X minus 1, it is a linear polynomial. Every linear polynomial is an irreducible polynomial, because this cannot be written as the product of two polynomials. So therefore we can conclude that every linear polynomial is a irreducible polynomial. And see this, x square plus x plus 1. So here x square plus x plus 1. So it is of the form ax square plus bx plus c with a not equals to 0. Its discriminant b square minus 4ac is 0. Then that polynomial is said to be irreducible polynomial. So this is here, x square quotient is a is 1, x quotient b is equals to 1, constant c is equals to 1. So now b square minus 4ac is b square 1 square 1 minus 4 into 1 into 1, so 4. So which is equals to minus 3 is less than 0. Therefore we can conclude that this is a irreducible polynomial. So we have discussed type 1 and type 2. In this class we will be discussing type 3 and type 4. So what is type 3 and type 4? We'll discuss now. This type 3 says, let f of x by g of x be a proper fraction. So first condition is this should be a proper fraction. Again, the proper fraction is nothing but degree of f of x is less than degree of g of x. I am telling you again, degree is nothing but the highest power, the exponent or the highest power of x in this polynomial is said to be the degree. Now let f of x by g of x be a proper fraction to each irreducible quadratic factor ax square plus bx plus c of g of x. There will be a partial fraction of the form ax plus b by ax square plus bx plus c, where a and b have to be evaluated. So to each irreducible quadratic factor of g of x, there will be a partial fraction of the form ax plus b by ax square plus bx plus c. Type 4. Type 3 says f of x and g of x be a proper fraction to each irreducible quadratic factor, each non-repeated. So it should not be repeated. So non-repeated linear factor. Type 4 says repeated linear factor. So let f of x by g of x be a proper fraction. So to each repeated irreducible quadratic factor of ax square plus bx plus c, since it is repeated a number of times, so there will be partial fractions of the form ax plus b by ax square plus bx plus c. So a1x plus b1 plus, if it is repeated twice, then a2x plus b2 by ax square plus bx plus c whole square. If n equals to 3, so this is 3 times repeated. So it will be a3x by plus b3 by ax square plus bx plus c whole cube. So since power n, so this is n times it is repeated. So this is anx plus bn by ax square plus bx plus c whole power n, where this a1 b1, a2 b2, a3 b3 etc. an bn are to be determined. But as far as the problems are concerned, we will be taking ax plus b instead of a2x plus b2, because the question will be giving finite number of repeated linear factor, whole square, whole cube, maximum whole cube. That's why ax plus b, if it is 3 times repeated, ax square plus bx plus c whole cube, then this is a cx plus d by ax square plus bx plus c whole square, a b c d. Now ex plus f by ax square plus bx plus c whole cube, where a b c d e f are to be determined. So let us start the exercise 7b. Now, exercise 7b, first question. Resolve the following fractions into partial fractions. So 2x square plus 3x plus 4 by x minus 1 into x square plus 2. So ask yourself whether this is a proper fraction or not. So the degree of numerator is x power 2. The highest exponent or power of x in the numerator is said to be the degree of the numerator. So here 2. Here x into x square, if you multiply x cube, so degree is 3 in the denominator. So 2 is less than 3. Therefore degree of f of x is less than that of degree of denominator. So this is a proper fraction. For proper fraction, partial fractions can be applied. And second question is, the denominator contains x minus 1. This is of the form ax plus b, because x minus 1 can be written as 1x plus minus 1. So ax plus b, this is the linear factor. And what is x square plus 2? This is of the form ax square plus bx plus c. Since a, b are used, I'll take px square plus qx plus r. This is of the form px square plus qx plus r, where the quotient of x is absent. And it is said to be the quadratic only, quadratic factor only. The immediate thing that we have to see is whether this is a reducible polynomial or irreducible polynomial. So x square plus 2. So we cannot express x square plus 2 to be the product of real factors. So of course actually x square plus 2 can be written as x minus 2i into x plus 2i. But these are the complex roots. So we want the real roots only. Therefore x square plus 2 is an irreducible quadratic factor. So, and how can we say it directly? See here, this is in the form ax square plus bx plus c equals to 0. So a is equals to, or p is equals to 1, q is equals to 0, r is equals to 2. b square minus 4ac, b square, so q square minus 4 PR. Its discriminant, let us see. If we will get less than 0, then it won't be have it won't have the real roots. So let us see this. So 0 square minus 4 into 1 into 2. So minus 8 which is less than 0. Since the discriminant we got it to be less than 0, therefore we cannot get the real roots for this quadratic factor. That is why it is said to be irreducible quadratic factor. So we have discussed much about this particular problem, and now let us do the problems. And one more thing is, x minus 1 is a linear factor. So type 1 and type 2 deals about the linear factor in the denominator. First one is non-repeated, second type is repeated, but both are dealing about the linear factors. So this comes under the first type because x minus 1 is not repeated. Therefore, this is non-repeated linear factor. And now x square plus 2 is a non-repeated irreducible quadratic factor. So type 3. This particular problem is the combination of type 1 and type 3. As far as type 1 is concerned, so a by x minus 1. To each non-repeated linear factor of ax plus b, there will be a partial fraction of the form capital A by ax plus b. So this is capital A by x minus 1. So here x square plus 2, for each non-repeated irreducible quadratic factor of ax square plus bx plus c of g of x, there will be a partial fraction of the form ax plus b by ax square plus bx plus c. So here a is used, so bx plus c by x square plus 2. So this is a by x minus 1 plus bx plus c by x square plus 2. So here x minus 1 is the only linear factor we have. Therefore equate it to 0, x equals to 1. So, and we don't have something to substitute for x other than x equals to 1. So now comparing the quotients of x square, x cube or constant on both the sides, we will be getting the remaining two constants as well. So this is how we have to do this particular problem. So a by x minus 1 plus bx plus c by x square plus 2. So this is 2x square plus 3x plus 4 by x minus 1 into x square plus 2. This is equals to LCM is x minus 1 into x square plus 2. So this is a into x square plus 2 plus bx plus c into x minus 1. So denominator on both the sides got cancelled. So 2x square plus 3x plus 4 is equals to a into x square plus 2 plus bx plus c into x minus 1. Put x equals to 1. So this is 2 into 1 square, 3 into 1. So 2 plus 3, 5 plus 4, 9 is equals to, if you substitute 1 here, 1 minus 1 is 0. 0 into this all will be 0. So a into 1 square is 1 plus 2, 3. So 3 3s are 9. So now let us compare the quotients on both the sides. Comparing coefficient of x square on both sides. Here the quotient of x square is 2. Here the quotient of x square is a. So here bx into x, bx square. So x square quotient is b. So from this 2 is equals to a value is 3 plus b. From this b is equals to 2 minus 3 is minus 1. Now comparing the constant on both sides. Or you may even compare the quotient of x also. So here constant is 4. So here 2 into a, 2a, which is a constant. Next here c into minus 1 is minus c. Because if you multiply this bx into x, bx square, bx into minus 1 is minus bx, plus c into x, cx, plus into minus minus c. So here, this is x square quotient, this is x quotient, this is x quotient, and the constant is minus c here. So, this is equals to 4 equals to 2 into a, 2 3s are 6 minus c. So, c is equals to 6 minus 4, which is 2. Therefore, the given one 2x square plus 3x plus 4 by x minus 1 into x square plus 2 is equal to the value of a is 3 by x minus 1 plus the value of b is minus 1 into x. So minus x, c value is 2. So 2 minus x by x square plus 2. Because this is b, b into minus 1 is minus x plus c value is 2. So minus x plus 2 I have written it to be 2 minus x by x square plus 2. Second question 3x minus 1 by 1 minus x plus x square into x plus 2. So the degree of numerator is 1, degree of denominator is 3. So proper fraction, and the denominator contains 1 minus x plus x square. It is a quadratic factor. Quadratic factor. Because it is of the form ax square plus bx plus c. And this is the linear factor. Because this is of the form ax plus b. So both are non-repeated linear factors only. Both are non-repeated only. And here, this quadratic factor, we should see whether this is the irreducible quadratic factor or reducible quadratic factor. So this is x square minus x plus 1. So a is equals to 1, b is equals to minus 1, c is equals to 1. So b square minus 4ac is, so if less than 0 we get, then this is the irreducible quadratic factor. If b square minus 4ac is not less than 0, that means is equals to 0 or greater than 0 if you get, then this is the reducible quadratic factor. So if it is a reducible quadratic factor, then we can express this into the product of two polynomials. Okay, so that is what we have to see. So b square minus 4ac is minus 1 square is 1, minus 4 into 1 into 1, so minus 4. 1 minus 4 is minus 3. Minus 3 is less than 0. Therefore, this is the irreducible. So type 3 deals with the irreducible non-repeated quadratic factor. So non-repeated irreducible quadratic factor type 3. So for every irreducible quadratic factor of ax square plus dx plus c of the denominator, there will be a partial fraction of the form ax plus b by ax square plus bx plus c. Here x square minus x plus 1 plus type 3 is this. So this is the non-repeated linear factor. So for a non-repeated linear factor, there will be a partial fraction of the form a by ax plus b, a by ax plus b. Since a is already used, a and b, so 3 by the linear factor here is x plus 2. So this is how we have to do this problem. So this is equals to ax plus b into x plus 2 plus c into x square minus x plus 1 by x plus 2 into x square minus x plus 1. This is equals to 3x minus 1 by x square minus x plus 1 into x plus 2. These two gets cancelled. So 3x minus 1 equals to ax plus b into x plus 2 plus c into x square minus x plus 1. So here x plus 2 is a linear factor. So equated to 0, x equals to minus 2 is the root, and root of solution has to satisfy the equation. Put x is equals to minus 2, substitute 3 minus 2 is minus 6, minus 1 minus 7 equals to. So minus 2, if you substitute here, minus 2 plus 2 is 0 into ax plus b. So this all will be 0. So c into minus 2 whole square is 4 minus x is minus 2. Minus of minus is plus 2 plus 1. So this is equals to minus 7 equals to c into 4 plus 2 6 plus 1 7. So 7 gets cancelled. C is equals to minus 1. Now we don't have the further linear factors. Therefore we cannot take something for x other than this x equals to minus 2. Now comparing the coefficients. Comparing the coefficient of x square on both sides. So here x square quotient we don't have in the LHS, 0 equals to. So ax into x, ax square quotient is a. Other than this, we don't get anything because ax into 2, 2ax, that is x quotient. B into x, bx, x quotient is b. But here we are taking the quotient of x square only. So b into 2, 2b, which is a constant. So here c into x square, cx square. So x square quotient is c. Other than this is x quotient, this is a constant. Now 0 is equals to a. The value of c is minus 1. So a minus 1 equals to 0. From this, a is equals to 1. Now the comparing coefficient of x on both sides. So here x quotient is 3. So here ax into 2, 2ax. So x quotient is 2a. So this is b into x, bx, x quotient is b. Next, c into x square, cx square. C into minus x, minus cx. So x quotient is minus c. So from this, 3 is equals to 2 into a value is 1 plus b, which is yet to be evaluated, minus c, minus of minus is plus 1. So this is 3 is equals to 2 1s are 2, 2 plus 1, 3, 3 plus b. So from this, b is equals to 0. Therefore, 3x minus 1 by 1 minus x plus x square into x plus 2 is equals to ax plus b. A is equals to 1 into x. X plus b is 0. So 1x plus 0 is x only by x square minus x plus 1 plus the value of c is equals to minus 1. So this is minus 1 by x plus 2 is the required answer. Third question, x square minus 3 by x plus 2 into x square plus 1. This is a non-repeated linear factor. This is the irreducible quadratic factor because x square plus 1, we don't have the roots here, real roots here. So this is b square minus 4ac. So this is minus 4 which is less than 0. So therefore this is the quadratic factor, irreducible quadratic factor. Type 3 tells about the irreducible quadratic factor only. So this is a by x plus 2 plus bx plus c by. So for every non-repeated linear factor, there corresponds to a partial fraction of the form a by ax plus b. For every non-repeated irreducible quadratic factor of ax square plus bx plus c of the denominator g of x, there will be a partial fraction of the form ax plus b by ax square plus bx plus c. So here a is used, therefore instead of ax plus b I have taken bx plus c by x square plus 1. This is a into x square plus 1 plus bx plus c into x plus 2. This is equals to x square minus 3. So taking LCM and cancelling the LCM on both the sides, this is what we are going to get. So x plus 2 is the only linear factor here. So x equals to minus 2 if we will take. Put x equals to minus 2. So minus 2 whole square is 4. 4 minus 3 is 1. So a into minus 2 whole square is 4 plus 1 5. So here minus 2, if you substitute here, this will be a 0. This is equals to a is equals to 1 by 5. Now comparing the coefficients of x square on both sides. X square quotient is 1. So here ax square. So x square quotient is a. So bx into x, bx square. X square quotient is b. So this is equals to 1 is equals to 1 by 5 plus b. So from this 1 minus 1 by 5 equals to b. So 5 ones are 5 minus 1, 4, 4 by 5. Therefore this is b equals to 4 by 5. Now comparing the coefficient of x on both sides. So here we don't have any quotient of x in the LHS. 0 is equals to. So here ax square, a into 1 a. So quotient of x square and constant we have here. So bx into x, bx square. Bx into 2 is 2bx. X quotient is 2b. C into x, cx. X quotient is c. Now this is equals to 0 is equals to 2 into b value is 4 by 5 plus c. 2 4s are 8, 8 by 5. So c is equals to minus 8 by 5. So we got the values of a, b and c. So substituting a comma b comma c in the partial fractions, we get x square minus 3 by x plus 2 into x square plus 1. This is equals to the value of a is 1 by 5 by x plus 2. So 1 by 5 into x plus 2. plus the value of bx plus c, b is 4 by 5 into x plus c value is minus 8 by 5 by x square plus 1. So this is 4x minus 8, take LCM 5. So a by b by c, a by bc. So 5 into x square plus 1. X square plus 1 by x square plus x plus 1 whole square. So this is a proper fraction with the degree 2 of the denominator of the numerator and 4 in the denominator. So partial fractions can be used here, and the denominator contains x square plus x plus 1. First of all, that is a quadratic factor. Further, which kind of a quadratic factor it is? So b square minus 4ac. b square is 1 square minus 4. 1s are 4. So 1 minus 4 minus 3, which is obviously less than 0. Discriminant is less than 0. Then this is the irreducible quadratic factor. This is a irreducible quadratic factor. So this is type 4. Repeated irreducible quadratic factor. For every repeated linear factor of ax square plus bx plus c whole power n, there corresponds to the partial fraction of the form ax plus b by x square plus x plus 1 plus cx plus d by x square plus x plus 1 whole square. So take LCM x square plus x plus 1 whole square. This by this. So x square plus x plus 1 into this. So ax plus b into x square plus x plus 1 plus this by this gets cancelled. We are left with the cx plus d. This is equals to x square plus 1 by x square plus x plus 1 whole square. These two gets cancelled. So here we don't have any linear factor. Had we have the linear factor, then we would have taken that linear factor equal to 0, then x equals to something we are going to get, and we used to solve, we used to substitute in the given equation. But here that is not possible because not even a single linear factor do we have here. Now all that we need to do is the comparison. So comparing the coefficients of x cube on both sides or x power 4 on both sides. So we don't have any, so x cube I'll take on both sides. So here we don't have any x cube in the LHS, therefore x cube quotient is 0 here. So ax into x square, x cube quotient is a plus, and we don't have any x cube other than this a, therefore a is equals to 0, directly we get. Now comparing the coefficient of x square on both sides. So x square quotient in the LHS is 1. So this is ax into x, ax square. So x square quotient is a. B into x square, x square quotient is b. And we don't have any other than this a plus b. So a plus b equals to 1. So 1 equals to a value is 0 plus b. So therefore b equals to 1 we get. Now comparing the coefficient of x on both sides. So here We don't have any quotient of x here in the LHS, 0. So ax into 1, ax. So x quotient is a. So b into x, bx, x quotient is b. Plus c into x, cx, x quotient is c. So this implies 0 is equals to the value of a is 0, the value of b is 1 plus c. So from this c is equals to minus 1. Now comparing the constants on both sides. So here constant is 1 is equals to b into 1 b, that is the constant, plus constant is d here. So b plus d equals to 1. So 1 equals to b value is 1 plus d. So 1 gets cancelled. We left with the d equals to 0. So we have a, b, c, d values. Therefore, x square plus 1 by x square plus x plus 1 whole square is equals to a value is 0. 0 into x is 0 plus b value is 1. So 1 by x square plus x plus 1 plus cx plus d. C is minus 1 into x. So minus x plus d value is 0. So minus x by x square plus x plus 1 whole square. X cube plus x square plus 1 by x minus 1 into x cube minus 1. Degree of the numerator is 3. Degree of the denominator is x into x cube x power 4. So degree is 4. 3 is less than 4. Proper fraction. So now x cube plus x square plus 1 by x minus 1 into x cube minus 1. So a cube minus b cube, a minus b into a square plus ab, x into 1 x plus b square. Because a cube minus b cube is a minus b into a square plus ab plus b square. So here a is equals to x, b is equals to 1. So this is what we will get. So therefore this x cube minus 1 is this. So x minus 1 into x square plus x plus 1. So now this further implies x cube plus x square plus 1 by x minus 1 whole square into x square plus x plus 1. So this is the denominator contains repeated linear factor type 2, non-repeated irreducible quadratic factor type 3. So this is the combination of type 2 and type 3. So x cubed plus x square plus 1 by x minus 1 whole square into x square plus x plus 1 is equals to. So for every repeated linear factor ax plus b whole power n of the denominator, there exists the partial fractions of the form a by ax plus b, b by ax plus b whole square. So therefore this is a by x minus 1 plus b by x minus 1 whole square. So now for every non-repeated irreducible quadratic factor of g of x, non-repeated irreducible quadratic factor ax square plus bx plus c of the denominator g of x, there exists the partial fractions of the form ax plus b by ax square plus bx plus c. since a, b are used, cx plus d by e. So this is cx plus d by x square plus x plus 1. So where a, b, c and d are to be eliminated. So x cube plus x square plus 1 by x minus 1 whole square into x square plus x plus 1 is equals to, this is x minus 1 whole square into x square plus x plus 1. So now x minus 1 whole square by x minus 1 into this. So a into x minus 1 into x square plus x plus 1 plus x minus 1 whole square into x square plus x plus 1 by this x minus 1 whole square. This gets cancelled. So b into this. b into x square plus x plus 1 plus this by x square plus x plus 1. These two gets cancelled. Cx plus d into this. Cx plus d into x minus 1 whole square. So here x minus 1 is the only linear factor. So put x equals to 1. First of all, you cancel these two. X cube plus x square plus 1 equals to a into x minus 1 into x square plus x plus 1 plus b into x square plus x plus 1 plus cx plus d into x minus 1 whole square. So put x equals to 1. 1 cube plus 1 square plus 1. So 3 equals to 1. If you substitute 1 minus 1 0, this all will be 0. So first term and last term gets cancelled because this is 1 minus 1 whole square. This also gets cancelled. So b into 1 square plus 1 plus 1. So 3. b is equals to 1. So we don't have something to substitute for x because x minus 1 is the only factor here, linear factor here. Now comparing coefficients of x cube on both sides. So x cube quotient on the LHS is 1. So if you multiply x into x square, x cube quotient is a here. So and throughout the entire, yes, here bx square. So this is cx plus d. On expanding this, x square plus 1 minus 2x. A square plus b square minus 2ab. So x square into cx. Cx cube quotient is c. So now a plus c is equals to 1. Here a and c both are unknown values. Now comparing coefficients of x square on both sides. So x square quotient on LHS is 1. So here x into x square, x cube, x into x is x square. So x square quotient is a here. X cube, x square, x minus x square. So if you multiply this, x into x square, x cube, x into x square, x into 1 x, minus 1 into x square minus x square, minus x minus 1. So x square gets cancelled. So we don't have the quotient of x square here. So since it is getting cancelled, so this, and here x square quotient is b. So here cx plus d into x square minus 2x plus 1. So cx into x square, cx cube, cx into minus 2x. So minus 2c x into x square. So cx into 1 cx plus d into x square dx square plus d into 1 d. So here x square quotient is minus 2c, x square quotient is d. So plus d. From this 1 is equals to the value of b is 1 minus 2c plus d. So 1 gets cancelled. So this is equals to 0 equals to minus 2c plus d. Now comparing coefficient of x on both sides. Here we don't have the quotient of x in the LHS. So here a into x into x square is x cube, x into x is x square, x into 1 is x, minus x square, minus x minus 1. So here we are comparing the quotient of x. So x again gets cancelled here. So in the first term we do not get any coefficient of x here. So now bx square plus bx plus x square, x constant, x quotient is b here. Now here cx plus d into x square minus 2x plus 1. Cx into x square, cx cube, cx into minus 2x, x square quotient, cx into 1 is cx, x quotient is c. D into x square, dx square, d into minus 2x is minus 2d. So minus 2d. And again, the value of b equals to 1. So 0 is equals to b value 1 I am substituting here, c minus 2d. So from this, this is what we get. So minus 1 is equals to c minus 2d, or 1 equals to 2d minus c. 1 equals to 2d minus c. Now comparing coefficient of comparing constants on both sides. So this is equals to 1 is equals to, so this is x into x square, x cube, x square, x. So minus 1 into x square minus x square minus x. So this is minus 1 into a minus a plus bx square bx plus b. So here cx plus d into x square minus 2x plus 1. So dx square minus 2dx, d into 1 is d. Now this is equals to 1 is equals to minus a plus b value is 1 plus d. So 1 on both the sides gets cancelled. So this is equals to 0 equals to minus a plus d. So these are the total equations we got. So this is 1, 2, 3 and 4. Here 2 and 3 are the simultaneous linear equation in C and D. So from this D is equals to 2C. D equals to 2C. Substituting D in the third equation. So 1 is equals to 2 into D value is 2C. 1 is equals to 2 into D value is 2C minus C. So this is equals to 2 to the 4. 4c minus c is 3c. So from this c is equals to 1 by 3. Now, so from this b is equals to 2c. 2 into 1 by 3. 2 into 1 by 3. So b is equals to 2 by 3 we get. So we got b, c, d. So we are only left with the a. So substituting d in the fourth equation. What is this fourth equation? Minus a plus d equals to 0. So d is equals to a or a equals to d from this. Therefore, a is equals to d and d is equals to 2 by 3. That means both a and d are equal. Therefore, x square minus 3 by x minus 1 into x cube minus 1 is x minus 1 whole square into x square plus x plus 1. This we have written before. So, a by x minus 1 plus b by x minus 1 whole square plus cx plus d by x square plus x plus 1. So we have all the values. The value of a is 2 by 3 by x minus 1. 2 by 3 into x minus 1 plus value of b is equals to 1. So 1 by x minus 1 whole square plus cx plus d. C value is 1 by 3. X plus d value is 2 by 3 by x square plus x plus 1. So take 3 as LCM. Take 3 as LCM. Then we'll get x plus 2 into x square plus x plus 1. So I have taken 3 as LCM. So this is x plus 2 by 3 into x square plus x plus 1. So this is the answer.